Let me check that Twitch has caught up. I seem to be live. Perfect. Welcome back, everyone. Sorry for missing the streams last week. New medication did weird things, and I was not in a state where I could stream. So let's get back into it. 2 weeks ago, then, we made some progress on continuing with the analysis, which has taken quite a while. That is like a long process. We're taking the past version of the code and we're going through name checking, type checking, on all that good stuff. We are almost done with checking constants declarations. We were missing one thing, which is we have to redo a small part of the code that already exists. Namely, we have to rewrite the import system that takes everything that is imported in scope and makes those names available in the scope. Because at the moment, we have no way to access the value of enums. I am going to make things slightly different than what Rust does here for the sake of our language being a bit simpler, but that's a thing that we're going to need to revisit. And the functions that were responsible for taking care of the imports were already quite complicated. So I think it's a good occasion to revisit them, clean them, comment them, and fix that problem with enums so that we can then go finish the evaluation of constants. Okay, so let's get into it. Oh, and one thing, I have not updated yet the YouTube channel with the history of the streams, but I have got. I think I haven't missed a single stream. I've downloaded everything before Twitch would delete them, so I should be able to update the full history soon. Okay, let's go. So, what we wanted to do was, after 2 weeks, after 10 days, I think this was here we have this init imported context and init local names, which sets the context of like, okay, when we look at the name foo in this context, what does it mean for the root of our module? And it uses what's imported and what's declared to initialize everything. However, again, it is not doing it for enums yet. So one thing I'm wanting to do is to see if there's anything that we can reuse between them, and I don't think there's a lot, because the bulk of what we have to do in the context of imported stuff is to make sure that we handle duplication properly. It is fine to import the same module twice, and as a result, the name should not be in scope more than once. It is, however, like very different to have the same thing declare more than once, so the duplication handling is different. Here, this handy to do, which is exactly what we're gonna try to tackle this evening. Do I start with the local declarations, which are a lot simpler, and then move on to imports? I might do that. So this is the list of all the top level names. For each of them, I get an identifier, the name, which is the thing that uniquely identifies a given construct in the code, and a corresponding declaration. And here, what I'm exporting is hash map to path to non-empty name. Okay. Oh, okay. So this is for each name, for each identifier in the scope, what is the canonical name of that thing? And this thing is me modifying the actual scope in the analysis monad to say, well, and actually this name points to this declaration whenever required. My plan for enums was to have the name point to the same name as the enum and basically use the actual text value to differentiate between this is a type or this is a enum value in the context. Which I think is fine. Is it actually? Is it actually? If I have someone do this, how do I handle it? Let's say I have someone do an enum color equals red green, blue. And then I have someone in a function foo do something like let color equals red. Because now I would have something in scope, but the name color in the scope would then point to a local variable in name, which is not the same thing as the name that uniquely identifies color. And when I try to evaluate the expression, red would point to this, and I would be able to differentiate between this is the type or this is one of the values. Yeah, okay. So I think despite this possibility, this still works. So that means that the mapping from name to declaration doesn't have to change. What needs to change is what top level names are accessible in the scope given their declarations. And I need to make a special case for enums, add more things in the top level scope. One thing that I'm doing differently from Rust, in Rust, oops, I need to make that a comment. In Rust, if I have an enum color, which is, red, green, blue, and I have some function foo that uses this color, for instance, takes a color as an argument, and it's a reference, something like this. If I try to match on that color, I can't use the name red, green, and blue directly. They are scoped. It's color red, and so on. I don't think I want to do that in this language. Hello, sorry, I had missed your message. How are you? I don't think I want to do this in this language because I think I want to keep scoping for top level things, as in each scope refers to like a very specific top level. It makes a lot of things easier, and we can always change the language when it starts working like in the future. Oh, is something weird with the... It looks like it's like OBS is capturing more than the window is not full screen. Weird. Oh well. Anyway, yeah, I don't think I want to do this kind of scoping at the moment in the language. I think that's too much work, and so I think I'm gonna do the same thing as like C++, I think, if I remember correctly, where just like if this enum is in scope, then let x equal red is perfectly valid and points to this red here. So we need to change this to instead create the hash map from path to non-empty name, but to change it so that enums add more than one path to this, which they already do. The only thing is that means we need to have access to the declaration, which we do. Perfect. Because that is, I believe, the declaration. And at this point, this is a bit inelegant, but at this point we have already handled duplicates. So there can only be one declaration for the name. So this pattern will match any non-empty list that has one element followed by whatever, but we know for a fact that this is always going to be empty. So now we can do something. We can decide based on what the declaration is, how we want to handle this. And I'm probably going to make this a new line just for readability later. A declaration. Yeah, this is weird. I'm just gonna very quickly look at this and see why it is like this. Is it because... No, my capture software is in full screen. Weird. I don't think it's too bad on the stream. Looking at the Twitch window, it doesn't seem to be too bad. Okay. So a declaration is one of those, and the only one that is going to be important here is the enum declaration. So we're going to handle this one. And we can handle every single other case as this fallback here. What this does here is basically saying, okay, in this map that we're creating of the paths that are in the scope, we're inserting the name of the current value, which points to this, like the identifier which points to this name. For instance, in the color example, the string color would point to the canonical name of the enum color that like fully uniquely identifies it. And we also use the fully qualified version because it might be good to disambiguate between different things named the same way. What we're going to do for enums is do the same thing, but add a bunch more for the values of the enum. If we look at an enum info, this is what we're going to need. We're going to need the enum values of the identifier. How do we do this? I'm tempted to keep this afterwards and therefore do something like map with enums be a temporary binding, which is going to be this. And in the enum case, we do something special. In the other case, we just return the map unchanged. And then we do the general case where we add those two things. Which means now what we do is we're gonna need to do. Can I do a union? Because I'm doing a bunch of inserts, but can I just rewrite this as a union? Probably. We have. Oh, I don't check. Ooh, I don't check for ambiguity. I don't consider enum names in the check for duplication within a module scope. That's something I need to fix. Okay, so I will be, I suppose, able to do this when I add the check that is missing. Okay, so this will be a union of the accumulator and a new hash map from list, which is going to be for each identifier enum value in the list of, how is it called again? In enum values of the enum info. We are going to return a tuple. No, actually, I'm not going to return a tuple. We're going to return two list elements. One is going to be just going to be the same thing as this, basically. It's going to be the tuple, this identifier pointing to this name. And it's going to be module name and the identifier pointing to this name. There we go. So that's going to be our list results. I just need to make sure the formatter is happy with this. Since this is a do block in the list monad, this is fine. But maybe I could write it not as a do block because then this makes it a tiny bit complicated. I could write it as a list comprehension. Nah, that's fine. Or I could write it as this is enum values bind into okay. Okay, so that creates the hash map and then that binds it, and then we add the name of the top level. Perfect. So now the thing that we're missing for the local names from list with combined locations. Okay. Okay, yeah. So that's the same problem there, where we're creating a hash map from the name of something, not the canonical name, the string by which it is known in this context, to the location at which it was declared, but I'm not handling duplication properly. Actually, let's have a quick look at Rust here. I'm gonna have to do some shenanigans because by default Rust does not do that kind of scoping for enums. I'm curious if I have an enum color red, that's enough. And I have a pub use, well, just use is enough, use color star in scope. And then I have a type red equals this. Does it complain about this red conflicting with this red in the scope? And use the import. Type yes. No, it doesn't. Okay, because it distinguishes between value level and type level, I suppose. That's something we could think. That's something we could add as well, I suppose. We could have something where like the scope is aware of like value versus type and only registers some things in the type or some things in the value, which would mean that like at the moment, since I share the same scope for all names, if a function tries to return a type of like main, the error message would be like, well, main is a function, not a type, instead of like being no type main found in scope. Would I want to make this change of differentiating value versus type? That would probably be quite a lot of work for a section of the code that we've already been spending quite a lot of time in. But this is not Haskell. We don't have any kind of like higher kindred nonsense and that data kinds and all that stuff. So the separation between value things and type things is pretty clear. Could there be any confusion arising from this? If I do something like I have type red equals I64 and I have const red which is an I32 which is 0, is that okay? Yep, it is okay. That's interesting. Do I want to do the same? I think I want to. I think it's a good idea. But the problem with this is it's gonna make a big change to some of the stuff we've done, because we've already done all of those functions. To try to resolve a value based on where it appears and look at its declaration. That would make a lot of code paths impossible if we were to do that. As in, the code that like looks up a name in the current scope would find, oh, I need to look at the declaration to know what this is. And despite the fact that we looked in the value scope, we need to be able to say, oh, this thing, like we would need to match on the possibility that this thing is a type, which would always be, if we don't have a bug in our code, an impossibility. I think it would be good, but I think that's not something I'm gonna change the code for now, at least. Okay, so that means I continue with the plan that we had at the start of the day. So I need to, in my top level names, oh, but if in my top level names I do not, if I do make this grouping to make sure I find issues with the enum names, oh, actually, I tried to type, I didn't try with. Okay, so that's fine. It doesn't complain about. But if I introduce a function, does it then complain that if I do I don't know, let's do instead a foo that. No, it needs to be a type ambiguous. So let's do this. I'm expecting it to complain about the two ambiguous reds. No, it doesn't. Huh. Does the constant take. Which one does it print then? 0. So it prints the constant. That's very interesting. Does it depend on the order of declarations? It does not. And if I remove this, color doesn't implement debug. Okay. So now it prints red, but if I remove the constant, it prints 42. Okay, so the constant takes precedence in the scope over the enum value. That is a bit surprising. I wasn't expecting this. I think I prefer the solution where we don't allow that kind of stuff at all. So that means I'm going to change top level names to also contain the name of the enum values in the scope, which means that here I will be iterating over top level names, which means I will no longer need to do this because the top level names will already be in the names will already be in the hash map. So we can delete what we've already done. And instead, go do it here. Because this is a list monad, so the value here needs to be a list value. Pure creates a list of one element. That's our base case. In the case of an enum, however, we're going to return more than one value. We can also just introduce the name here. Because even in the case of an enum, this identifier, which is the name of the enum, will be used to uniquely identify the enum. I've written too much Rust recently. I'm introducing semicolons in my Haskell. Okay. I think I've just been naming this name fairly consistently, so I should probably... but I have this name in scope, which is the module name. I should probably change that, replace this name with module name for clarity, okay? And this is now declaration name as opposed to module name, just to be clear. Okay. And so here, instead of returning a one item list that contains this, we do the same thing we did before. We return a list of more than one element, in which we have... Oh, wait. This top level names is... Oh, it's just the identifier. Yes, we don't have to handle the... We don't have to handle module names and everything here. This is just purely the identifier at the top level. So here the list will be one for each value plus this, I suppose. So this will be this exact thing at the beginning of a list obtained by doing what we were doing, which is for each enum value in the enum values of the enum info, return the create an element in the list, which is this enum value, which points to the declaration of the enum. Okay, now they are in scope, which means that then when we get to this part, they are added automatically as both their version and the fully qualified version. So that's done for local names, and now they are included in the duplication of top level names. Okay, that's good. And now we need to do the same thing. I should probably try to compile this first. Oops. This is no longer something that exists. Ah, those are with location. So this would be a with... Well, I guess I can just like... unwrap the location, I suppose. And here the declaration is no longer used. I can go back to just matching underscore. Okay. That means that if we go back to our test file, I have a test2 folder, which is the highlight of... wait, is it not test2? I had a test file. Was it just test then? No, this is test is the actual... There's a test3. That one. That's the one. Software development in a nutshell. Test3. There we go. Now, what I wanted to test, I had this file I was testing a few things in. What was the state of this? Error name not found. Foo? Yes, because I'm trying to do a cast to a type that doesn't exist. Perfect. Let's comment this out. What I would like to try now is I have red in scope here. What happens if I introduce type red equals int in this file? Now, okay, error multiple declaration for red. The first time is the location here. Okay. Oh, I don't include the declarations in this. I don't include the declarations in this diagnosis message. I probably will want to do that when it's time to actually report error messages. So I can say, well, this is a type alias declared here and a struct here or an enum value here, something like this. But I don't do that yet. But we do report the error multiple declaration, so that's working. The other thing I would like to check is now, can I introduce const r, which is a color equals red? Or did we not finish? Not a const red. Okay. Yes, that is a. We haven't finished the constant evaluation. When we encounter a name here, we refuse functions because non-functions call cannot be part of a constant value whose value must be computed at compilation time. And as a result, at the moment, all the names that are just not a constant, we reject. We're going to have to allow for enums as well. Okay, let's progress. I'm going to leave this file like this. I now want to do the same thing for the known symbols. Yeah, okay. That I remember. I'm glad I left comments about this. To handle duplication, because the same module might be imported on more than one line, which is perfectly valid. Uh, I create a hash map from the module name to a hash map of, okay, this name in this current module points to that thing, and then I do some deduplication operations. And so this is, why am I doing it as a list of a hash map module name? Why am I doing this and not just a tuple module name hash map? Is it because one declaration can result in more than one? I think that's the case because a use statement can be used with like an alias, but the fully qualified version should also be in scope. Oh no, I'm just returning a singleton for each of them. Interesting. Is it just because it makes doing the union easier? Probably. Okay. So here the question is, how do I avoid duplicating the enum logic 3 times? Because I have 3 kinds of import. Exhaustive, we import with a star, we import everything, and therefore all the symbols must be in scope. Names, where it means I need to be able to handle all names, and I'm handling specific names from the scope. And qualified. Actually, do I need to do anything? I don't. I don't, because now I have handled local enum values being put in the scope. As long as the module exports them properly, then all 3 of those will handle them properly. I don't have to add anything here, I think. And it will be the job of this analyze thing, which for now returns this maybe symbols, which is not a great type. We need to return more things than this. But this will be, as long as this contains the symbols for the enum values, then I don't need to do anything as far as this is concerned. And at the moment, yeah, for now, I am not exporting them out of the modules properly because I am creating only one symbol per um, per declaration I encounter. So here I will need to fix this as well. Okay. Do I want to fix this now? I think there's so much that needs to change about this function that I think I'm going to add a to-do for now. Okay. But otherwise, I think this is good enough for now, which means we can go back to here. This gigantic thing, this gigantic piece of code is looking at the expression of a constant and making sure that it's all fine. We have this gigantic big blob of code which is for handling casts within within a constant expression, because constant expressions are in line. Field access is not done yet. Struct expression is not done yet. Call expression is, I don't have an error message for it, but that's not something we're going to allow. I think the thing we're missing, I think everything else beyond this is done. We're missing some error messages. I have a few, like reward fail, I have an undefined. That's the case. Oh no, this is Boolean comparison. We haven't done those yet. Okay. Range. The problem is that we don't have any support for vectors and lists at the moment yet, so that's something we're gonna need to figure out at some point. Okay, I guess for now I can change this resolve const. And I need to change it to resolve const value, I suppose. Because in this case, I'm gonna have to support so I looked at the name of the path that was given to me, and it happens to be pointing at an enum. Now the big question is it the type or is it one of the values? And let's see. Oh. I guess this depends on wait, why am I doing this? Why am I calling resolve declaration here? So I already have a declaration. I am in the context of this was a declaration. Why am I doing this? Why am I doing in the context of I have found a const declaration and I'm doing a resolve declaration again? Why am I doing this? Oh, yes, of course. Of course. That's because that's the shenanigans we had to deal with a few weeks ago. This function, this resolve callback, takes a declaration which is either already resolved, because it comes from another module and we've already compiled it, or just passed, because we have not yet compiled. We have not yet compiled. It's from the current module. As a result, I do not know at that point, like it could be either type. And if I want to look at the actual resolved values, I have to call this, which if it's already resolved is a no-op. If it's not, then call the resolve top level function and detects cycles. That's what this is. Here for the enum, however, I'm not sure the compiler will let me, but it should be possible to not do that because the enum info does not contain any information that changes based on the actual analysis of the code, because it just contains a list of identifiers which doesn't need to be resolved in any way. So I can try to see if it allows me to do this, because this expression does not depend on the hidden existentially qualified thing in this. So what I need to do is I need to get the last element of the path info. The path info is, I think sadly it currently is just a list, something we would absolutely need to change at some point, because that's not, I think it's just a non-empty list. Name type. This is going to be a resolved name, I think. Okay, now this is the resolved name, and I have the original name there. How do I get the actual identifier of this? Because the resolved version, the name, not in this module. I guess I would get the identifier, but it would be pointing to the enum. It would not be pointing. So no, I need to look at the original path info here. So this is the original path that I do have in scope, which again is the name type during the past phase, which has, as we have indicated, is a path. Okay, and a path is a non-empty list of identifier. Okay. Does non-empty, does it have a last element? I would assume so. Yep, it does. Perfect. And it's deterministic because a non-empty list is non-empty. There's no risk of it. It's not a partial function. Perfect. So I can get the name, well, the identifier, I guess, as identifier as being the last of the original path. Am I actually in the monad? I think I am. I think I am in the, yeah, because I have this reward veil here, so I can just do that. Now, I can do, if identifier is the same thing as the enum name of the enum info, then we tried to say, like, that our constant had something named after the type, which is not valid, which is constant value. We've changed the call site, which means this case will be this. That's not a constant, that's an enum. Now we need to handle if I look at data list, because, well, non-empty, this isn't, is it an non-empty list? No, I think the enum values, it's a normal list. Okay. That means we support empty enums, I suppose. I want to find, but find is takes a predicate. Is there just a lookup? No, lookup is, I want index. LM index, that's what I want. I guess I can do it as an if then rather than a multi-branch if, because I'm gonna want to do a case of the LM index of this identifier in the enum values of the enum. If it's nothing, that means we did not find the thing in the enum. That is impossible, that's an error. Otherwise, we did get it, and that's the index I. And here is where we're going to be returning a typed expression. And a typed expression, if I remember correctly what we have decided, is the type and a value, which is an expression. And here I'm going to do something a bit sneaky. The path info resolved is this one. And the expression we're going to use to represent this value in our constant enum values are just going to be represented by an index, which means this is actually going to be an int literal expression of I. Okay, the formatting here is abysmal. Let's fix this. Okay. So here, that this is a user error, which will be surfaced to the error. You try to give to get a value, and you gave us a type. This is an internal error that is impossible. That means this name that we associate with an enum is neither the type name nor one of the enum values. How did that happen? That's a bug in our side. And here is we did find the enum, and we resolve it to a literal expression. Okay. Aha. I do have a few elements from a list in scope, so last needs to be qualified to be the non-empty version. And here I'm returning a typed expression, but this needs to be put in the context of the monad in which we are. And I can do it at either level. Let's do it here, just in case I end up handling internal compiler errors in a monadic way. Okay, that seems to compile. Which means now if we go back to test 3, whatever it was called, this one, now this should work. Okay, so it did finish the analysis phase. The symbols that were exported, so yes, we do not yet export the symbol for red, that is missing. However, R here is indeed a constant. Its name is R. its type is of color, which is a top level declaration in the module main, and the expression is a typed expression of type color and value int 0, because this is the 0th value of the enum color. However, this plus 3 shouldn't work, and we should get an error because we've tried error wrong type, because we are expecting a color and we got an int. So despite the fact that the underlying representation of an enum is an int, we are not allowing this. However, this should work, but I don't think works yet. Oh, it does. Did we do that? That's always good news. Let's see the gigantic handling of expression for constants. Here for a cast, what do we do? Ah, yeah, we try to resolve enum from name for the type. Oh, we even handle error enum out of bounds. Nice. So I can try then to go back here, and we check that this was 0. Let's try the other way around. 0 as color. And that is indeed okay. It was accepted. This is a value of type color whose value is under the hood an int 0. And if I try 3, however, I should get an out of bounds, error in them out of bounds. Perfect. Okay, so compile time conversion between enums and ints seems to be working. I wonder if can I try something a bit absurd? Something like saying that this is read as int times 30 times 90 plus 5 or something like this. Built-in type int. Yes, and the whole thing needs to be as character. And we get this, which I have no idea what this is, but if I try GHCI and I ask for the character that maps to 90 times 0, yes, I should have. There we go, because I was going for 95. Okay. And 95 I get underscore, and if I do this and this, I do get underscore. Perfect. Okay, so this is starting to work. This is working. Now, where were we? Because now that means, in the case of a constant value, handling an expression that is a path to something else, that's handled. Handling a cast at compile time, that's handled. There's a few internal compile errors are not handled gracefully yet. There's, I think, a few error missings. I think our diagnostic type is for now just a bunch of undefined in a bunch of places. I guess I could do struct expressions are going to be complicated. I should keep them for last, I think. Let's do instead. Let's do instead. Yeah, let's do the equality ones, I guess. But that's That means handling struct values. That's going to be complicated. It might not actually be. Let me have a quick look at expression. If I go back to the AST, what's a struct expression? Because we're going to be, if everything goes well, since we are resolving the values at compile time, we're going to have basically something resolved to a literal expression of one of those, one of the built-in types. Or, if it's an enum, it's going to be an int anyway. And otherwise, it's going to be a struct. We don't handle vectors yet, which are going to be a special case, which will be an array expression. And otherwise, the only thing it could be would be a struct expression, I think. And that's not the end of the world. We just need to be sure to compare things pairwise and not compare them in order. Okay. Let's do it for just this one and see how we can then generalize the code to the others. We are implementing equals equals on two values that are known at compile time. So we're going to need to do somewhat of the same thing that we do here. We're going to need to resolve. We need to go recursively on the two different types. This function is getting a bit big. So we recursively go on the left-hand side and the right-hand side. Now we can check that if T1 and T2 are not the same, we can report an error. Because we have a value of type T1 on the left-hand side and a value of type T2 on the right-hand side. If they're not the same, we were expecting T1, we found T2. They're not compatible. And I guess here, then we have to do if the types are the same, we do have the guarantee that their actual values will be the same underneath. The only thing we need to do is to handle the special case, well, the same, will be of the same specific sub kind of expression if everything works well here. So I think the only case we need to handle is when we have a struct expression, basically. Because those I can't just do equals equals on, because the order in which the fields were given might not be the same. So what is a struct expression? That's path info, which is the name, okay, and then the non-empty list of identifiers. I don't care by which path the struct was referred to, because it could be the fully qualified version or the non-fully qualified version, but that doesn't matter because what matters is the value. And we have already checked that the types are the same. I'm only interested in this version. And the annotated expression at when the thing is already resolved Annotated expression resolved. Ah, it's at the end of the file for reasons. Yep, it is a typed expression. Okay. So that means I don't need to compare the types of the fields for a structure because that's already going to be checked. The creation of the struct expression in the first place, if we get if we resolve to a struct expression, it means the types have already been checked. So I don't need to perform any more checks here. I can just, so that's going to be fields 1 and struct for fields 2. Here I basically need to do a smart comparison function. And in any other case, this returns pure of a Boolean. Is it bool literal expression? There we go. Which at compile time is computed as being simply is R1 equals to R2. Oh, but that means we're gonna need to implement equality on expression that we don't have yet. But I think that's fine. It's fine to use the built-in definition of equality because here what I'm testing is literally are those the same Haskell constructors. This is what I'm checking. So it's fine here to use the equality, I think. Okay. So now what I need to do is I need for each field in I know that the fields are all there, so that's gonna make it easier. I just need to make sure that can I just sort the fields and do a zip basically. If I do a sort, it's gonna be sorted on I can sort by identifier, I suppose. So this would be the values of something that's sorted on the identifier. Okay. And I'm not just gonna map to second, which is the typed expression, but I'm gonna go one step further. What's a typed expression? I want the exp value. Okay. But here, however, is where I need to be able to call this piece of code recursively, because if those are the values are of type struct, I cannot just use the equal equal there again. I have to do the same thing. Which makes me wonder if I should just, instead of using the non-empty list of identifier, if I should rewrite my If I should rewrite, no, I can't. Even if I rewrite my struct expression so that instead of being a non-empty list of identifiers as they appear in the code, it is a hash map from identifier name to value or something like this, which we need to change based on whether it's passed or resolved. That would be a nightmare. I still couldn't use the equality, the generated equality function to check that two values are equal, because again, one side could have referred to the struct by an alias and the other by another name, and yet it's still the same type. So I am going to have to export this to another function. A comparison expression, which is going to take as an argument a function that to an expression passed and an expression passed will give me a boolean, which is going to be a comparison operator, and is going to give me then an expression passed, not passed, actually, I'm wrong, resolved. And that's going to be... Does it need to be in the monad? Surprisingly, it might not. This might be able to just be a pure, regular, normal function, because I think we have everything we need at this point. Okay. Because that's the complicated case that we need to handle, but the base case is just... Come on. It's just we're returning a boolean, which is, are those two things equal, basically, which instead is actually operator applied to R1 and R2. Try E1 and E2 now. But this is where it gets complicated, because now I have the expression value on both. And how do I do comparisons of like greater than and so on structs? Do I just say that it is simply that it's true for all of the values, all the fields pairwise? That feels reasonable. That just means that all structures have comparison built in, but that doesn't shock me for like a language like this. So that would just be that all uncurry up for zip sorted F1 sorted F2. Except nope. All comparison expression. Well, I guess this is no longer, this is compare expression at this point. Compare expression. Or I guess, so I call this recursively on the fields. So if two fields are both two integer expressions, we can check that they're the same. Otherwise, if they're both structs, then we call this recursively to make sure that we handle structs properly. Okay. Which means here I can go back to this And the result will be pure of a Boolean. Well, this becomes a when t1 is different from t2, and the result is a pure bool literal expression, which is initialized with compare expressions. Is it not called compare expressions plural? Hmm. Compare expressions. This would be R1, R2. Okay. And the operator we will compare them with will be this. I'm gonna need another thing. I am going to need I hope I'm gonna need probably the ORD constraints. So here, what I'm doing is, since I have this complicated system where like everything in the AST is indexed by which phase we're in, making instances such as like, oh yeah, there's equality and ORD for an expression requires saying that like, hey, all of those types that depend on a phase actually have this as well. So I need to declare like, I use an alias here to say, here are the constraints I require to be able to make an ORD instance. And here I can therefore say, if the phase P matches all of those constraints, then we can make an ORD instance for the expression at this phase. Okay, so now we should be able to generalize this to all of them, to the point that I kind of want to do another function here, which this time will be called comparison expression. Which will be this. Which resolves the two left-hand side, right-hand side. Reports an error in case of an issue, and then creates the Boolean literal expression. The only thing is, it's going to require the operator given as an argument there as well, so that it can give it there to compare expressions, which still needs to be a separate function because it needs to be self-recursive. And this is going to be, as a result, something like that, except it's going to be taking the expression. Oh yeah, passed. This is wrong. This is not expression passed, expression passed. This is expression resolved. But here it takes the expression passed, expression. Well, no, actually, no. It takes the expression resolved as well. Because it's gonna give this down to this function. But it takes as argument the past version, because that's the thing that actually does the resolving. Here, however, we are not able to return purely a Boolean. We are in the monadic context of our analysis monad, which is how we can do this and this. It will short circuit appropriately if an error happens. We do type checking there, and then we call this. Okay, perfect. So now, with this done, I can rewrite this as being comparison expression with equal for E1, E2. This is the same thing, but with the difference. Okay, let's compile this. Okay, so we're missing a few things. Annotated expression. Okay, so here in my, I am missing annotated expression of p, which I am assuming means I'm gonna be missing ord here. Okay, ord path info. Oh, that's gonna be annoying. Okay. Okay, that should be fine because there aren't that many thing. This equals instance require more things in the AST to have equals instance. Likewise for this OR instance, but I think it's only this one so far, which could be worse. Although I guess in the worst case, I could just write them manually because I'm using the generated one, which is going to be like in a lot of cases useless. Yes, I did not name those. Those are called E1 and those are called E2. And for the sake of vertical alignment, there we go. Okay, we should be able to test our comparison expression in constants now. Except those are with location. Okay. Yes, this is not a boolean here. This is... Oh, this needs to be a typed expression, actually. And for this, let me see what I've done for boolean expressions. I've used an alias here that I'm going to reuse again, which is defined here, I think. Bool expression. Oh, it's not here. Why is it defined then? Is it here? It's here. A Boolean expression is a type expression of the Boolean type with the Boolean literal expression. Okay. Next. Wait. I am decomposing this as being a typed expression T1R1 in the recursive call, in the call to go. And a typed expression wait, no. Why is this path info resolved, which is the first argument? Why does it require... Because it's all name types. Why is it complaining about typed expression not being... Hmm. That is completely wrong. Okay. So there's a few things wrong here. First, I need to check I do have ORed on the expression. Something is wrong in this. Because I do have ORed on the expression, therefore this should be like greater than and less than should be valid values for this type. But why on earth? Oh, is it because the error wrong type? No, actually, it is in stages analysis diagnostics. Wrong type is taking a path info resolve, which I think this is. So T1, T2 should be path info. And path info does have an equality constraint, which only depends on yep. This equality constraints depends on an annotated expression because of the expression. Because otherwise the equality instance doesn't exist. Okay, yeah, no, that's fair. That's a correct complaint. That means I need to go to type expression. And I need to duplicate some of this. Which is a tiny bit annoying. Where are you, typed expression? Yeah, okay. I'm gonna need to do it that way. With that, we should be good. Okay, there we go. Which means we can go back to this nonsense. And we can try a few more things. I don't have the ability to do struct expressions yet, so we can't yet do things such as like comparing struct expressions. But I should be able to do something like this. Boolean. And check that it is correct. I'm gonna comment all of this out. Okay. Oh, interesting. I do get a compiler here. Wait, did I get a compiler here? I did get a compiler here. Interesting. I'm fascinated by the fact that it doesn't work with the ORD thing. I'm expecting that there's another place where I have an EQ instance, but I don't have an ORD instance. which seems to be name, as far as I can tell, from the error message. Huh. Oh, yes, of course, name isn't declared in this. That's why. And now that should be it. I'm compiling with tests here, which means I have to recompile everything. And then when I switch back to here, I'm going to have to recompile everything. Oh well. This binding. Aha. Because I do have. I'm gonna just hide the lens one, I think. Okay, so now it builds. So now I can go back here. So if we look at B1, bool expression true. Perfect. This was resolved to true at compile time. Perfect. Now, can we try? Can I try saying red equals 0 as color? I get true. Perfect. Can I try red as int equals 1 just to be sure that it's doing comparison? False. Perfect. If I try to do red equals 0, I should get a type error. Expecting int got expecting color got int. Perfect. So that seems to all be working perfectly fine. And I don't have struct yet, so I cannot do struct yet, which means I guess that our next step is struct expressions. Okay. And having proper errors would be nice at some point. Because we handle path expression, cast expression. What are we missing? Array expression is the same thing as range. We're going to need to have some idea of how to support arrays, which we don't have yet. So for now, I'm not going to handle them. And therefore, index expression is not going to be done yet. But I think beyond that, the only thing that's missing is struct expressions. Let's do that, which is here. Yes, to do. Thank you. Passed to me. Maybe the type doesn't need to be in the struct expression. It has to be because I'm using the same, because the way I'm using the ST between the past version and yeah, okay, so it has to be there. That's fine. Now, resolving the type. So here I have some path, which is supposed to be the type name of a struct. So resolve struct of that path is indeed what we need to do. Let's have a look at resolve struct. There we go. This is once again one of those things where I just call resolve path with a resolve callback. Anything that's not a struct gets an error, not a struct. A type alias, I have to go recursively and try to see if I can get I have to resolve name. And here, okay, I get the info. I can check the type parameters, and then I return. Perfect. That gives me the resolved path info. Okay. And the struct info. Okay. So that's resolve type indeed, and resolve and struct info, I guess. Which is the declaration. Now I'm gonna need to check the fields. What do I need to check? I need to check one, all the fields are there, and two, there are no duplicates. When that's done, what I will get is indeed, I think this is correct. That's going to be a typed expression of the resolved type, in which the structured expression is the result type and the fields. And the fields are a non-empty list of... They are a non-empty list of identifier and expression. Okay. Actually, do I already support... I think I do, right? Because I think in the test foo, yeah, I support that. So I could try already just for the sake of here having an x which is an int and a y which is a bar with struct bar being something that contains an int named z or something like this. Ah. Mistakes were made. I should have compiled in here first. Because now I have to recompile everything. It's probably just only those things. That's the last thing I've changed. Indeed. Interesting. I'm giving resolve type, which is the first part of my tuple, which I believe to be the path info, and it tells me that this is actually the okay. Wait, what? You're what? Okay. Just to check that this wasn't a problem of me not having saved. It was a problem of me not having saved. Okay. If any of you could report the bots, that would be nice, because I can't report just by clicking. I would need to get the other keyboard, which is there, to actually type a reason for doing the moderation. Okay, so just to check what is wrong here. Oh, it's because I have left here this. So I need to go back to doing this. Okay. And indeed, foo is a struct declaration in which the name is foo and the values are x, which is an int, and y, which is a bar. And bar is a struct that contains a z that is an int. Okay, so that still works. Okay, so I guess the only thing left to do is to resolve the fields. So again, I need to check two things. I need to check exhaustivity and non-duplication. What's the best way to do this? What is a struct info? Let's have a quick look. It is a non-empty list here because that's how it's declared. I want to keep the order. Okay, so because I don't want to do a linear lookup in everything. That seems because also I will need to do it both ways, which is kind of a mess. So I think I am going instead to call a separate function, and I'm gonna resolve struct analyze struct fields because it's going to be useful beyond the context. And this is going to take on the left-hand side the non-empty list of fields, on the right-hand side the actual provided fields, and will either surface an error within the monad or give me the resolved fields, and then I can just call this. Perfect. So now I can introduce analyze struct fields, which on the left-hand side will give me a non-empty list of identifier and their type. On the right-hand side, a non-empty list of identifier and the typed expression. The order doesn't have to be the same. And so here I will return, if all of this is correct, actually they're not, at that point they're not passed yet. But I guess I could do that before calling this function. Actually, oh, that's annoying. Actually, this function does not return anything interesting. It just checks that it is correct. Because whatever this is going to be, like this resolved thing, that is what I'm going to give to the extract expression anyway. So it just needs to tell me whether this is correct or not, basically. Okay, to do later. But I need those to be typed expressions, which means that here, back in this gigantic mess of a function, here, The fields I'm gonna need to, before I can do that, I'm gonna need to first resolve them. There we go. And those resolved fields, is there, actually no, I guess I could, because there's no point in calling analysis in something that is the wrong. But I can't know the type before. I guess for the wrong name, I wouldn't need. Like if someone tries to initialize a struct with a field X that happens to be that doesn't exist in the struct, there's no need to actually do analysis of the. It's probably better to do it anyway because it would be better to give them errors if the expression is wrong, just because they might just have gotten the name wrong. Okay, yeah, no, let's do that. So I want to resolve the fields, which is a non-empty list that I want to translate into a non-empty list. So it's going to be an fmap of resolving this, basically, well, traverse of a traverse, rather, of resolving this expression. So this is going to be a traverse of a traverse of analyze expression, I believe. How is this called? Of go, of course. This is my local function. Of go on the fields. And here I can give those the resolved fields. I check that they're fine, and then I give them to the type expression here. Perfect. So now we just need to do that, which is going to be, okay, I have those two lists of two non-empty lists of identifiers. I need to check that both of them have exactly the same names, and I need to check that the second list doesn't have duplicate values. As I say, I can just like do the same thing I did earlier, which is like sort and zip them. But the problem with that is I'm not gonna be able to give very good error messages. I'm gonna say like, oh, for the field X you gave me something Y, but that's not gonna be able to distinguish between like, oh, this is a duplicate field because there was already a Y before, or it's actually not. It's a thing that doesn't exist. So if I want to give good error messages here, I'm gonna have to try to be a tiny bit smarter than this. Let me think. I guess the easiest is just to translate that those into hash maps, basically. So let's do that. So it's going to be fields one is going to be a hash map from list of just to a list of the, because I don't think this takes. Oh, do actually hash map strict. This is the Rust hash map. This is the Haskell hash map. Does it from list actually take. It doesn't take a foldable, it takes an actual list. Okay. Okay, so that's going to be. See, here on the left is type info and reference fields. Reference values. Okay, and from this, I can do now from list with, and I'm gonna concatenate. And here I am going to do a thing where I fmap pure in the values. So I'm putting each type expression in a list. So this becomes a non-empty list of tuple of identifier list of type expressions. And then I'm creating a hash map in which I combine similar keys with concatenation, which means that for the field, for a given name, I will have a list of values that were associated with it. Now, I can do the first step, which is for every value in the reference, which gives me an identifier and a type, I can do a few checks. It's not get, where is it again? Lookup. If I look up this particular identifier in the values that were provided, what do I obtain? Empty list, that means the value was not provided. Report fatal. And let's do it properly this time. Diagnostic. Error struct missing field. I'm gonna give you the type of the struct and the name of the field, I guess. So this is the path to... I don't have... I need to give that as an argument. I will need the path info resolved, which is the name of the type for the error messages. Okay, type name. And the field that is missing is identifier. If instead, I guess I can handle this case here, which is one element, and then I can handle the case of more than one element. Oh, welcome. So here, I'm here. I am doing I'm analyzing an expression that creates a struct in the context of a constant declaration. And I am doing this thing where, okay, I have this list of fields as they appear in the definition of the struct. I have this list of values that were given to me in the struct construction expression, and I'm checking that it's fine. So I'm doing this double hash map, and if I'm expecting a value because it is part of the definition of the structure, but it is not part of the values that were given to me, I can report an error that the struct is missing a field. If there is only one value associated with it, that's the good case. We're going to handle this. If we have anything else, I guess I can give this a name in case it ends up being useful for the error. I need to report an error to the user. This is the kind of stuff where, like, I probably would want to have a slightly smarter thing where, like, since it's a writer monad, not an exception monad, it doesn't necessarily short circuit immediately. I could try to be smart and like have a way to report several errors in a row rather than just erring on the first for this expression. But that comes much later. Error handling for now is extremely bare bones. So here this would be a new error, which is error struct duplicated field. For the type name and the identifier. And here this case is the interesting case. For now we don't have any use for this. Now, this is the interesting case. For one of the values of the structure, we found one values in the expression. So we can check. What do we need to check here? I think the only thing we need to check is the type, I think. And as a result, I think the only thing we need to do is, because this x is going to be a typed expression, what I can check is when the expression type of x is different from this, because that's a... Yes, that is correct. If it's different from this, which is the type path, so if the types don't match, then I can, there again, report fail, and the error will be, it is going to be a very simple error, wrong type. An error, wrong type, we are expecting type path, and we got the expression type x. At some point, I'll change those report functions to actually not just return this enum with information, but like an actual structure that also contains the location and a snippet of the code, but we're very far from this. Okay, so that checks that for everything that we want, we have one matching definition and that it happens to be correct. Now, we do need to do the other check, which is for, and I need to use a for that disregards its result because I don't care about it. For the values map, for the values, for the fields, which gives me an identifier and a typed expression, which I guess I don't care about in this case, because the type checking has already been done. I only care about the name. I want to check basically that all names that are in this hash map are actually within, in this list, are within the hash map. So here this is very much a when not lookup the identifier in the reference map. Report fatal error. Oops. And this is gonna be error struct unknown field. And this unknown field requires the type name and the identifier. Okay. And that should be enough for the type checking, which means we can go back to this nonsense. And this is only missing one thing. It's missing the name of the type of the structure, which is the resolved type. Okay. Let's try this. Oh, yes, of course. This is wrong. This lookup doesn't give us a list, it gives us a maybe of a list based on whether the list was found or not. And the empty list case doesn't make sense because it would mean we have found the name but there was no value associated. So I will need to handle the nothing case and the empty list case separately. I guess I am just going to do a fold of this and handle both the nothing case and the empty list case as one, because the empty list case is theoretically impossible in the first place. When not lookup is not the correct word, the correct function. I don't want to do lookup. I want to do, is there a member function that tests whether, yes, there is. Just need to check whether that thing is part of the map. And if this compiles, we can make some tests. And if it does, we might be done for now with analysis of constant expressions, because string values, arrays, vectors, all that, that's none of it is ready yet, which means we can probably just move on to actual functions. Okay, this compiles. Let's go back to our test file. I'm gonna put this, I'm gonna comment this out. Let's try this. I want a constant foo that happens to be an int, and I want it to be... Oh, I don't have call expressions yet. Okay, so for now, let's try to just have a foo thing. Oh, let's try to have a boolean where I have here foo int with an x0 and a y being a main bar with z being 1. And let's make sure that the thing where the order doesn't matter is still working. I want to check that those two are equal. Delimiter braces open. I have some unclosed braces somewhere. Oh no, I think I changed the syntax since we're using happy for the parsing and it was very annoying with some things and not allowing ambiguous grammar. We couldn't do the exact grammar we wanted. And if I remember correctly, as a result, we have made one change to the Rust-like grammar just to avoid an ambiguity, which I think is specifically for the case of struct expressions. Let me check that again. I think, if I remember correctly, struct declaration is not what I want. I want struct expression. There we go. Yes, and the at symbol that was added specifically for this, because otherwise it's too ambiguous. And here I want to try naming bar, not... I want to name them differently in each context to make sure that the resolution is working. Okay. Ah. 67. Oh, here, yes. Ha. Oh, because I have a missing semicolon here. My parsing errors are not great yet. Okay, so this constant foo is a constant. Its type is a built-in type boolean, and its value is true because those two things match, which means foo and main foo, it pointed to the correct declaration. It checked the fields based not on the order but on the field. Okay, that seems to be working. Now, I guess the only remaining thing really, I think, for now, because we support all the operators here, range requires vector we don't have yet. Everything else here we handle. Array index requires arrays vectors we don't have yet. Call expression is an error, I just don't have a proper error type for it. And everything else, yeah, so the only thing that we're missing is a field access expression. Okay. Let's do that, and then we can try seeing if we can access fields of this thing here. Actually, I'm going to try to see how it's rendered here for now. If I do this and this, what do I get? I get an error because I forgot the semicolon. Okay, so this is a const info. The type is a top-level declaration of foo in main with no type parameters, and is a typed expression of type main foo in which the value is a structural expression. that repeats the type name and contains x, which is a typed expression of type int and of value 0, and y, which is a typed expression of type bar, which contains a struct expression of type bar with a field z of value int and 1. Okay, yeah, that seems to be working just fine. So let's go back and let's do a call expression. That's the thing we're missing. So first, let's go back to the AST. Let's see what a call expression is. It is a not call expression. Call expression is something we want to handle. It's field access expression I want to do. Field access expression is here a expression which should resolve to a struct and an identifier. Okay. So that is an expression, and that's a field. So what we have to do, get the typed expression, the by just going recursively on this subexpression. And here, I guess we can do a case of the struct value, because here in an actual function where we don't have the value at compile time, I would need to do a lookup of the type. Okay, this thing gave me a type foo. Is this thing a struct? Would this be valid? Here, instead, I can just, since this is a constant and I have the value at constant time, I can just check whether that thing is actually a struct expression. If it's not, then I can just report a type error. Is this a struct expression of a given type and a bunch of fields? If yes, we can do something. Otherwise, and I guess what do I want? I probably want. I guess I probably just want to type, yeah, the type of this is not a struct. Error field access, not a struct, with the type, which is the struct type. And otherwise, we do have the expression. We know it is a struct by construction, and we have the fields. And the only thing is, we know, since to construct a valid struct expression at constant time, we have already checked that the fields are all correct. It's just a matter of basically finding the field's value in this. Yeah, I guess that's it. How do we do that? Do non-empty list have a find function? They don't. But they are foldable, I think. They are a foldable one. That means they are foldable indeed. And I think foldable has a find. Yep. So what I want to do is, so that would be the field type, the identifier I don't care about, and the typed expression or field value, which is what I care about. Well, actually, it's gonna depend. But now this is gonna be field info, which is gonna be a maybe because a find will return a maybe. This is going to be a find of the first part of the tuple is equal to the field here. So this identifier here matches this. And that find is done on the fields here. That gives me a maybe value because maybe the field was not found. And I guess I can do directly a case of this thing. Or I can do even and do this and do an on nothing. And on nothing will be a report fatal of something. And then here I'll be able to do pure field value. Which means this is in fact just fmap second of this. And I just need to introduce a new error for this. Field access field not found for this type, which is the struct type, and for the field, which is field. Okay. And I think that's enough. Let's check. Oh, does it compile first try? That'd be nice. Ooh. That is always a pleasant surprise. Okay. So now I can try here to have this thing be an int and be this struct value. Or I could do it as a separate function, actually. Foo is going to be a foo, and it's going to be this thing. Let's not forget the semicolon. And this z thing is going to be an int, and it's going to be foo dot y.z. So I'm expecting z to be 1. Oh, will this conflict with... No, probably not. Okay. Z is a constant with the name z with built-in type int, and its value is a typed expression of type int with value 1. There we go. And now if I try to do z2 here, I should get... Okay, error field access field not found. That doesn't z2 doesn't exist in a main bar type. And here, if I try to do x1, I should get an error struct duplicated field. X appears more than once. And if I do z equals 42, I should get struct unknown field. And finally, if I forget the x, I should get error struct missing field. There we go. Whew. And with this, I think everything we can handle at the constant level, we're handling. Because we're handling paths, just to check that we are handling constant values. I think here we could test, if we haven't tested yet, this orb. This should not be allowed because this is a function call. It should just crash because oops, because I did not have a proper error handling for this. It crashed at line 524, which happens to be... Yeah, we found a call expression in a constant. And if I try to reference Zorb the function here, I'll get an error, which is that's not a constant. Therefore, it cannot be referenced into a constant. That's fine. So path expression handled, cast expression, we've tested a few things. That seems to be just fine. We don't support cast expression between user-defined types, and I think that's fine. Type aliases will always be resolved, so there's no point in doing that. Yeah, I don't think we want to deal more than that at this point. Field access we've just done. Call expression doesn't make sense. Array and index depend on arrays we don't have yet. Struct expressions we've done. Literals we've done, except for strings, because we don't have strings yet because they depend on arrays. References we don't handle in constant. Negation we have handled. I guess the bool negation I should do bitwise negation as well. We can do that later. Addition handled, subtraction, multiplication, division, okay. Yep. I think that's all for constants. Which means we're done with analyzing type aliases, structs, enums, type matches. Why do I have... Oh yes, I know why I have this. I've been using the equality comparison in the constant, and I was worried that I should have been using this. The reason I have this is because I want type checking to short circuit in the context of generic functions that have type expressions that have like you are using generic types, because those are going to be resolved when the functions get instantiated, which we haven't done yet. Okay, that was a lot. And I guess the next big one, which is going to take, I think, a lot of time, is going to be analyze function. Because now that's the last type of declaration we haven't handled yet. We are going to need to go through all the statements and do all the same kind of analysis. And yeah, but I think since that's a pretty significant milestone, we're done with analysis of constants. I think, and I've been at it for more than 2 hours, I think this is going to be good enough for this evening, and I am going to stop here. However, after the stream, I'm going to do the thing I haven't done last week, which is to update the YouTube channel with the all of the streams, and I'll push the code on GitHub because I am, I think, 2 weeks back on that. And if anything happens to this computer, I would like to make sure that there is a backup. So yeah, that's going to be it for this evening. Thank you for tuning in. We've made some good progress, and I'll see you on Thursday.